Hello world, good morning, good afternoon, good evening, and welcome back to Robo Thoughts, ladies and gentlemen. This is a special series Robotics and Vision Intelligence on Jetson Nano, and we are on lesson number 25, multiple ultrasonic detection through ROS serial in Jetson Nano. It's going to be wonderful and a long, lengthy lesson, guys. So, in the previous lesson, I showed you how to use a single ultrasonic sensor connected to your robotic operating system ROS serial through Arduino and Jetson Nano, and you are able to read the parameters and manipulate that, right? Now I am going to show you how to connect multiple sensors. In this lesson, I'll connect 3 sensors, but in practical, you can connect n number of sensors. It's possible. Yes, I had tried it out. It worked great. All right. So basically, guys, this is little complex. We are going to get into more complex stuffs, and I'm sure you guys will really enjoy this. In this lesson, I'll show you how to connect 3 or more ultrasonic sensors to ROS serial and detect the range from multiple angles like front, back, center, left, and right, okay, in all the directions. You can fix the sensors depending upon what kind of robotic structure you build, and depending upon that you can build your the range detections, okay, in from ROS real. Now basically, guys, you need to understand that in ROS framework there is a package called sensors underscore message. Before I get into that, let me show you the basic circuit diagram what I have put together. All right, so this is the basic drawing where you will connect 3 different sensors. It's pretty simple drawing, guys. All the ground pins are common connected. All the VCC pins, that is your positive terminal of the sensor, is again common, and your ground is connected again to the ground terminal of Arduino, and then your trig and echo pins are distributed evenly between pin number 6, 7, 8, 9, 10, like that. All right, and then obviously your Jetson Nano is connected to your serial port of Arduino, and we will be using 5 to 9 volt of battery connected to your breadboard. All right, I have used breadboard, and the way I put together, let me show it to you. So this is how I have connected my Arduino and Jetson Nano with 3 different ultrasonic sensors, okay, 1, 2, 3, and all the common grounds are connected together. All the VCC points, the red pins, are connected, and then I have connected 2 different batteries like this, okay. You can use any of the batteries, and I have just used whatever I had in my inventory, and then I programmed it. So this is how it looks, and I am going to show you how to take it forward from here. All right, guys, now the most important aspect, right? So I have documented, I have posted the image of the circuit drawing in my GitHub repository, so you can take a look at it. And I have also documented the entire code, okay. It's about 161 lines of code in Arduino based on C++. But however, I need to explain some of the libraries, right? For example, there's a package called sensor underscore messages, right, which consists of a collection of messages for commonly used sensors. With ultrasonic sensors, basically we use the range message type, okay, the message which we collect, and we launch a topic on ROS, and what kind of range it is detecting. So this message type sends a single range between the sensor points, which is valid along an arc of a distance, okay. So you need to understand this. And then we also import a couple of other libraries like for example, simple Kalman filter, which basically is used to filter out your ultrasonic sensors output. And also we import another library called new ping. It's an Arduino library ping, which is used for your HCSR04 ultrasonic sensor. And then we also import ROS.h, which is our standard library for robotic operating system. That library has to be imported. And then we will have another library called ROS/time.h header. Okay, this is another basic library used in ROS clock. Okay, this is to calculate the time it takes to trigger and echo the signal from one distance to other distance in a message definition used to basically advertise a single range reading from the ultrasonic sensor valid along an arc at a distance measured. Okay, this might be a little confusing, but once I start showing you the code, you can probably understand, especially people from Arduino background and C++. All right, so that's very important, guys. You need to understand the C and C++ language in addition to Python programming. This is very critical. As we get forward, we are getting into more advanced stuffs. All right, so now let me open my Arduino, Jetson Nano. I am on my terminal. Let me open up Arduino and let me see what it says. Let me just check if my circuit is connected properly, because that's very important. It's very critical to make sure that battery is connected. Right, and then what else? Yeah, this is fine. Okay, I think we are good enough. Okay, all right. Anyways, let me just start it up. All right, guys, so let me open up Jetson Nano and I'm going to open my Arduino. I have already loaded the program, but just in case for you guys to understand what it does, let me just make the screen a little bigger. Right, so this is about 161 lines of code to be precise. Let me just enlarge this, guys, so that you guys can see the codes line by line, and I will try my best to explain. Let me make it 24. All right, this is pretty big. All right, so as I said earlier, so we will be importing a library called new ping, which is basically for your ultrasonic sensor to read, and the simple Kalman filter library. So I'm going to post all this library zipped file in my GitHub, guys, so you can download directly from there. All right, you don't have to search in Google and kind of thing. It might lead to multiple other libraries, but yeah, you can get into my Git and directly take it up. And our favorite ROS.h and ROS/time. So these are the basic stuff, and then we will be setting up the number of sensors. I had set maximum 3, and then we can also set the maximum distance to 200. Basically, that is the max for any kind of object to be detected, right? And then what we need to be what I would like to show you is probably on line number 10, we also on line number 13 at the bottom here, we will import the ROS packages, some of the packages which we already done, like ROS.h and time.h. And then we will start creating some of the new pings which will basically trigger the entire stuff, right? So I will show you how it works one by one. I tried to document this separately in a separate Word document. I had already put it in my GitHub, so take a look at it. You will understand. It's not that complex. If you understand C++, I think it's pretty logical flow. So what we need to do, go to tools and then go get the board info, get the port, make sure that you are on the right port. All right, guys, that's very important. And my port, where is my port? It's not detecting my port. Oh yeah, there you go. So I am on ACM 0, and then let me just minimize this. All right, so once we minimize, we need to now run the commands. So what are the commands, guys? The most important aspect, you need to initiate ROS, right? Your ROS core. So how do you do? Open terminal, and my terminal is hiding somewhere in the corner, so let me just drag him up. Alright, so what's the command? ROS core, ROSCORE. With a little luck, exception cannot, what's happening? Started ROS launch, okay. Cannot run another ROS core, maybe I think it's already running. Let me just close it out. Hold on guys, give me a minute. Did I run this early? Yeah, that's the reason. I think it's already running. Anyways, let me close this. There you go. I forgot to shut it down before I started showing you guys in the video. Anyways, let me restart again. Alright, open terminal, and my terminal is here. Okay, ROS core. Okay, ROS core. That's the command you need to initiate to activate your ROS in Jetson Nano. Alright, I hope it runs. Yes, it is. Okay, there you go. At the bottom it says started ROS core. And minimize this, guys. You need to minimize the terminal, never close it. Okay, now what we need to do, open another new terminal. Okay, let me drag him up, and this terminal will, the below command is, this particular command is to basically establish a ROS real communication between Jetson Nano and Arduino. Okay, so it's very important guys, you need to keep running this terminal again and again, as I showed you in the previous chapter. ROS run, ROS runs space ROS serial, okay, underscore Python space serial underscore node dot py space /dev /tty, and my port is ACM0. In your case it might be different. Alright, it's connecting, right? The setup publisher. Oh, can you see that guys? The ultrasonic sound underscore left, center and right. So all the three publishers are getting through. Now let me minimize this, not close it, mind it. Now what we need to do, let me open another terminal. Now see, there are three different topics we publish, right? I have a bad throat today guys, sorry for that. So we have three different sensors, three different topics to be published. So how do we see that whether it's really communicating? So it's called list, it's called a topic list. So let's open ROS topic, ROS topic space list. Okay, so this will basically display the range of all the sensors activated, so that you need to initiate the list in, you can initiate the list in the ROS, and you can, by executing this command, it will show the list of sensors, or it can be three. In my case it is three. In this lesson I am showing you three sensors, but you may add about 20 different sensors. So this particular list should ideally show up if everything is hooked up correctly, the circuit is perfect, and your code is working, then automatically that should detect. Okay, let's see. There you go. So I can see the ROS out and the aggregate ultrasonic underscore center, left and right. Okay, now we don't have to close this window. Now let's read the distance detection, range detection from each sensor. All right, how do we do that? ROS topic echo / ultrasound. Okay, ultrasound underscore, which is the first one is center, and the left and the right. Okay, let's read the first one. It does not appear to be published yet. ROS topic echo, why it is not published? It is published already. Let me control what's happening. Control C. Let me relaunch this, guys. Sometime it happens. Let me relaunch. It is already published, right? Can you guys see what mistake I did? Let me close the terminal. Why am I not able to close? Okay, there you go. Let me close. Okay, and then let me come back and see if there is any other terminal. I think, yeah, there is one more. Let me close this as well. Close. Let us relaunch. I hope this time it runs. Hopefully. Okay. Now let's see. Let's launch our ROS core first. Okay, this is my terminal. Let me launch ROS core. Started the core service. Okay, let me minimize. And then let me open up another terminal. Let's give the access for serial ROS run ROS serial underscore python space serial underscore node dot py space /dev /tty acm0. Connecting, requesting topic, setup publisher. Okay, this is published. Now let's open up the list, the ROS topic list, in a new terminal. Okay, how do we open? ROS topic space list. All right, there you go. Now let's launch one of the sensors and let's see what it does. ROS topic. Do I have to open another terminal? Not sure. ROS topic. Let's give a try. Echo space / ultrasound underscore center. There you go, guys. We are reading the first sensor, which is a good news. That's your center one, right? We have one sensor placed in the left, one in the right, and one in the center, and this is the range. Can you see that? Can you see the reading, guys? Fantastic. All right, now let me just put my hand in between. Yeah, the value changes, right? Can you see that? The sequence and the stamp and the range, which is a good thing. Now let me exit. Say Control C. You need to use Control C and it will stop. Okay, now let's run the next. Let me clear this. ROS topic echo / no, let's launch the list first. ROS topic list. Now what do we have? We tried center. Let's try the left sensor. Okay, ROS topic echo / ultra sound underscore left. I hope this works. Yes, perfect. So the left sensor is detecting your the distance between whatever the object is. It's sitting in front of me, so obviously, yeah. I'll just show my hand. There you go. It's just trying to sync it up. Good. Now let's check another sensor. Control C, clear, ROS topic list. All right, now we have we tried center, we tried left, now we have right. ROS topic echo / ultra sound underscore right. Fantastic, guys. So even the right sensor is working, so that's really cool. All right, this is perfect. See, can you see the range? It's changing. Good. Now control C. Let me come out of this, and then let me yeah, I think that's that's pretty much, guys. So what you need to do is first you get 3 sensors or 4 or 5 and follow the same structure, right? You make a common ground for all the sensors, whether 3 or 4 or 5 sensors, okay, and then the common VCC. Okay, use a breadboard like the way I have used it. Let me show it to you again. So it's here. It's very easy to connect through the breadboard instead of soldering the PCB and stuff like that. So what you can do is, instead of 3, you can connect 4, 5, 10 different sensors, but make sure that you have a common ground and the common VCC pins. Okay, once that is connected, you can assign your digital pins. So we have limitations in Arduino UNO, but if you use Mega, probably you will have more number of pins, right? So that can be integrated as well. And then once you do that, it's pretty simple to follow this drawing, the circuit diagram. Connect your Arduino through the serial port to your Jetson Nano, and then you get into the coding aspect, which I have already documented very well. All right, a well documented code is there already. If I have to explain you line by line, it's going to take about 3 hours of video probably, right? And that's going to be, you guys will get bored. So I have written down everything, and if you don't understand any specific line, just do leave me a comment or email me. I can answer and reply to you as quickly as possible. All right, guys, I hope you are enjoying. I'll be back soon with more number of lessons, and it's going to get more and more complex and kind of thing. So I hope you guys are enjoying. Bye bye. See you.